Most of us already have a sense of how the climate is different in different places. Imagine that you had a magic portal that could instantly transport you to anywhere in the world. But you don't get to look at the weather forecast before you get out of your portal. How would you know what to wear? Obviously, your magic portal has an infinite wardrobe of things you can choose from. Whoosh! If you got out in Seattle in winter, you'd expect it to be rainy. Whoosh! Australia in summer, you'd expect it to be hot and sunny. Whoosh! Chicago in winter, really cold and probably snowy. This is the concept of climate. These places all have different climates, and that controls what the weather there is likely to be. But what controls the climate?
Climate is a fundamental property of how energy is moved around or redistributed on Earth. But where does all this energy that we're talking about come from? It comes from the sun. The sun provides the energy that is responsible for weather, as well as the same energy that keeps plants, animals, and even you alive. But not everywhere on Earth receives the same amount of sunlight. Places by the equator, the line between the north half of the Earth and the south half, get much more sun than places by the north or south pole. That's why the equator is so warm and the poles are so cold and snowy. But why do these equatorial regions get more sunlight? To answer this, we need to think of the direction sunlight is traveling in, relative to the Earth's surface. The surface of the Earth at the equator is perpendicular, meaning at a right angle to the sun's rays. This means the rays hit directly into the surface. But at the poles, the surface of the Earth is parallel to the sun's rays. They go in the same direction. This means that very little of the sun's energy actually hits the Earth's surface here. You can feel this effect yourself. Think of a time you played outside on a sunny day. If you were lying down flat, like a sunbather, the sun would directly hit a lot of your body and you would begin to heat up. But if instead you were standing straight up, or doing a handstand, then the sun's rays would be parallel with most of your body, so you wouldn't get as much heat from them.
So we know that places near the equator get more direct sunlight than places near the poles, and this makes them warmer. This is part of what gives different places different climates. But the climate isn't quite that simple. The Earth doesn't like to have one part of it so much hotter than other parts, so it tries to even them out. The atmosphere and ocean transport a lot of the extra heat energy from the equator regions to the polar regions. Not enough to make them the same temperature, but enough to make the temperature difference a lot smaller. This redistribution of energy creates the atmospheric circulation, or movement of air, that helps give different places different climates. Close to the equator, the circulation created by this redistribution of energy is called the Hadley Circulation. This gives us tropical rainforests near the equator and deserts on either side of these rainforests.
So the sun is the main driver of Earth's climate, but volcanoes, large ice sheets, and humans all influence the climate too. You may have heard of anthropogenic or human-caused climate change. This is when the actions of humans, such as producing electricity from coal or natural gas, driving cars, and even farming, release greenhouse gases into the air. These greenhouse gases make the Earth absorb more energy, and this makes the Earth warmer.
But this warming doesn't mean every year is going to be hotter than the one before. Even though temperatures are rising generally, some years are still cooler than others. To demonstrate this, my height on the rope represents global temperature. The higher I am, the higher the temperature. Notice how I'm climbing up and down. This is because some years are cooler and some are warmer. But with anthropogenic climate change, I climb up more than I ever climb down. And so overall, I, and the temperature, keep getting steadily higher.
But we don't have to be stuck up there. If we work together to decrease the amount of greenhouse gases we're putting into our atmosphere, we can stop the changing climate and bring global temperatures back down to what they were before we changed them. Thanks for watching! We hope you enjoyed learning about what climate is.